Okay, let's look at the second part of section 3.2, talking about the empirical rule. So now the main tool you need in this section is to understand what the empirical rule is telling us. So the empirical rule has three parts. And the first part, or each part tells us what percentage of our data we can expect to fall within a certain range on a normally distributed data set or a symmetrical data set. Okay, so first part of the empirical rule tells us that if we start at the mean, and if we figure out our standard deviation, whatever that number is, and we go that far up from the mean and that far down from the mean, so we're +1 standard deviation and -1 standard deviation away from the mean, that's our range we're looking at, then the empirical rule tells us we've got about 68% of our data in there. And so more than 2/3 of our data is going to fall within 1 standard deviation of the mean. Okay, if we go out 2 standard deviations above the mean and 2 standard deviations below the mean, what portion of our data is going to be in that range? Well, the empirical rule tells us that about 95% of our data is going to fall in that range, so almost all of it. And then if we go out one more standard deviation, so we're going up 3 standard deviations from the mean, down 3 standard deviations from the mean, and looking at that range of values, then in that range, the empirical rule tells us that about 99.7% of our data is in there. So very unusual for a data value to be more than 3 standard deviations away from the mean. Okay, so let's look at solving some problems using this information. Alright, so this one says, suppose shoe sizes of American women have a bell-shaped distribution. That tells us we can use the empirical rule with a mean of 8.36 and a standard deviation of 1.5. Using the empirical rule, what percentage of American women have shoe sizes that are between 5.36 and 11.36? Okay, so you can work these problems several ways, but my suggestion is to sketch out what we're looking for and sketch out our bell-shaped distribution. Our mean here is 8.36. Okay. And then let's mark off where our other standard deviations would fall. So I'm trying to make it look like this picture where I've got 1, 2, and 3 standard deviations above and below the mean. So if we go, now our standard deviation is 1.5, so I'm going to do 8.36 plus 1.5. That's going to get me to 9.86. So I'm just adding the standard deviation to the mean. And then I'm going to do the same thing again. So if we add another standard deviation, so plus 1.5 again, we get 11.36. And then plus 1.5 one more time, we get 12.86. We're going to do the same thing going down. So 8.36 minus 1.5 gives us 6.86. Minus 1.5 gives us 5.36. And then minus 1.5 gives us 3.86. Okay. So making that picture, you can solve any of these problems. Okay, so that's my first step on all of these. And so now we want to look at, we can label these in terms of standard deviation. So our mean is right here in the middle. This is +1, +2, +3 standard deviations. This is -1, -2, -3 standard deviations. So what are we looking at? We want to know what percentage of our data is between here, 5.36, and here, 11.36. So how much of our data is going to be in that range? Well, the empirical rule tells us within 2 standard deviations of the mean, we've got 95% of our data. So 95% is our answer on that one. And that's one of the easier ones. If it says between 2 numbers, it's just straight from the empirical rule. Okay. Let's look at one that's a little bit trickier. Let's look at this one. This one says, suppose IQ scores have a bell shape with a mean of 105 and standard deviation of 15. What percentage of IQ scores are no more than 20? So I'm going to start out the same way. I'm going to get my picture made, and then I'll worry about answering the question from there. So my mean is 105. I add 15 to that, I get 120. Add 15, I get 135. Add 15, I get 150. Okay, I'm going to do the same thing going down. So take away 15, I get 90. And 75. And 60. Okay. Then I'm going to figure out what the question's asking. So this one says, what percentage is no more than 120? So this is our max. And we can go as far to the left as we want to. We just can't go above 120. So on these, the empirical rule is not quite enough information to be able to solve the problem. You got to think about one other thing. You got to remember that this distribution is symmetric. It's symmetric and bell-shaped. So that means that from the mean, 50% of the data is on one side, and 50% of the data is on the other side. So that tells us that if we go right here on our little interval, from the left of there, we've got 50% of our data. So we're only missing this little piece between 105 and 120. So if we think about standard deviations, this is 0, this is +1, this is -1. So we're trying to figure out this piece between 0 and +1. We don't know that directly, but what we do know is that between -1 and +1, what percent do we have? We have 68%. Well, we only want half of that. So half of that number is going to be 34%. Okay. So then all we have to do to get our final answer, we've got 50 plus 34 gets us 84% of our data. We're done on that one. So that one's a little trickier, but it's still doable. Okay, one more, but it's similar. Okay, those can be a little bit tricky, so we'll get one more. Oh, give me just a second to fix this. I accidentally put the same problem in twice. Okay, new problem. Same context, but we got different numbers here. So this time we've got a mean of 104, dealing with IQ score, standard deviation of 15. What percentage of IQ scores are at least 89? And so, always, I'm going to start with my picture. 104 there. And if I go up a standard deviation, that's 119. Go up another standard deviation. Nope, not 214. Go up another standard deviation. 119 plus 15 is 134. Go up one more standard deviation. Get 149. I do 104 minus 15. Get 89. And really we could stop right there because that's the number that the question's asking us about, but it doesn't hurt to go ahead and finish the picture out. Okay. So here we've got 0, and this is -1. It's +1. Okay, so this time the question says what percentage of IQ scores are at least 89? That means 89 or more. Okay. So we're going to have pretty much the exact same problem as last time, it's just pointing the other direction. Okay, so remember we got 50% on this side, 50% on this side, and so that means from here up we've got 50% of our data. Again, we want this area in here between plus or minus 1 is 68%, but we only need the left half of that, right? We only need this part. So divide that by 2, we get 34%. Okay. So again, our final answer is going to be 84%. Okay, it won't always be 84% because it could ask us for this number over here, 74. And then we would have to take half of 95 instead of half of 68. But they'll be similar to that. Okay, hope that helps.